Now that we have our applications built, let's look at testing, debugging, and deploying our applications. Let's do that by taking a look at the Windows Azure architecture and specifically the Azure data centers. Here's the data center in the cloud. It is a collection of commodity hardware, a collection of storage servers with triplicate replication. You have your service, which is any app you want. You also have load balancers, which are responsible for distributing incoming traffic to each role instance. There is a fabric controller, the brains behind it all. You also have a web portal, and this is where you deploy and manage your applications. It's all about running your service in the Microsoft Data Center. Now let's take a look at the service deployment. It's so easy, even a CEO can do it. From a service deployment perspective, you have the service, which is the application you want to run. You also have the model, which is the service configuration, which, among other things, specifies what the service looks like and how many instances you want to run. Today, you must deploy your service through the portal. In the future, there will be an API available that will allow you to deploy your service through the command line, TFS build procedures, and other types of automation. In this scenario, we are deploying our service through the portal. We upload the two files, which are the service package and model configuration. The Fabric controller reads the model configuration, which describes how to deploy our service. In this case, we are deploying our service to 3 machines. The Fabric controller determines which 3 machines to deploy to, copies the service package to the 3 machines, and fires up the services. The Fabric controller then configures the DNS so you have an endpoint exposed for your services for the outside world to communicate with your services. From there, it configures the load balancers and routers. That's it. It's completely automated. Service scaling allows us to use the web portal to spin up more instances of our service, as well as remove instances of our service that we don't need based on load. The Fabric controller is the component that is monitoring our services. If for some reason one of our instances goes down, the Fabric controller is notified and spins up another instance of our service and takes a bad instance offline. As part of getting ready to develop applications for the cloud, you installed the Windows Azure tool for Microsoft Visual Studio and related SDKs. This SDK includes a local cloud emulator that provides cloud functionality on your local desktop, including real Fabric and Fabric controller. This SDK provides almost all of the cloud functionality needed to develop and test your cloud applications. It does need and use a local instance of SQL Server to simulate Azure storage capabilities. And the great thing about the emulator is that it provides a great way to debug your application by providing a few tools, such as the Compute emulator to watch your processes. When running and testing your applications, you can get to the emulator via the blue flag icon on your task tray. Clicking this icon provides the ability to look at the details of the instances you are running locally. You can view the application you deployed, the different roles of that application, the specific instances of each role, the details of each instance, and via the menu bar you can start and stop a specific instance. Through the emulator, you can also look at the status of your Azure storage, including starting and stopping one or more components of your Azure storage. The local emulator uses SQL Server to simulate Azure storage. If you have SQL Express installed as part of the Visual Studio installation, the storage emulator will auto-configure SQL Express on the first run of your cloud app. However, if you have both SQL Express and SQL Server installed, you might run into a problem where the storage emulator will error during initialization. You can also use a different SQL instance, and you can initialize your Azure storage by using the ds-init command. For example, if I want to use my default instance of SQL Server, not SQL Express, I would simply execute the ds-init command, specifying the SQL instance parameter with a value of a dot to signify the default instance. If I have and want to use another SQL instance, I can simply use the same command and specify the specific instance, such as an instance named Azure Test. You can also include code in your application to determine whether you are running in the Fabric or not. Via the Windows Azure Service Runtime namespace, You can use the Role Environment class to help determine whether you are running inside or outside of the fabric. So now let's take a look at debugging your application. Because of the emulator running on your local desktop, you have the ability to debug most of your application as if it were running in the cloud. You can debug locally just like any normal ASP.NET application, including full support for multiple instances. Debugging is done through your normal breakpoint process that you know and love. Windows now supports IntelliTrace, although it does require Visual Studio 2010 Ultimate, and thus requires that your applications be written in .NET 4.0. When using IntelliTrace, an agent is deployed to each of your instances, which gathers and reports all debugging and stack information. Once gathered, you can then replay the app locally. Via the Windows Azure Activity Log, you can view the results of the trace and look at the IntelliTrace summary in Visual Studio. You can view the summary by right-mouse clicking in Visual Studio and selecting Get IntelliTrace Logs. Let's take a few minutes and look at the configuration files that exist in the Azure project. Configuration is handled by the service definition and service configuration files. Role-specific information is contained in the service configuration file, and the service-specific information is contained in the service definition file. So let's take a peek at a sample service definition file. In this file, we see that this application includes both a web role and a worker role. The web role has its defined external endpoints, while the worker role is internal and by default has no exposed endpoints. The service configuration contains the service name, the role name or names for each role in the application, and the instance count for each instance. It also defines the specific configuration information for storage and diagnostic settings. Now let's talk about the different ways you can deploy your code to Windows Azure. You can use Visual Studio, you can use the portal, or you can script your deployment and use the Management API to deploy your code and your application to Windows Azure. When deploying to the cloud, you must first create an Azure account, then a service, and then deploy your code. If you're deploying through Visual Studio will build two files. One is an encrypted package of your code, and the second file is your configuration file. The initial deployment can take up to 20 minutes, and this is because it first needs to upload the file, build the IIS application, and then extract those files into the IIS application. Now, doing this on-premise usually takes about 6 months, so 20 minutes is much better than 6 months. In a development scenario, you can use the web deploy to deploy your applications. So now let's take a look at deploying your application to the cloud. In this example, we are going to deploy a web role application to Windows Azure. This is really a two-step process. Step 1 is to create the deployment package in Visual Studio, and Step 2 is to create the actual Windows Azure service in the management portal and upload our deployment package. So let's begin by opening Visual Studio and opening our web role application. Here we have our web role application. There's our ASP.NET application, and there's our Windows Azure web role project. We begin deploying our application by right-mouse clicking the Windows Azure project and selecting the Publish menu from the context menu. This brings up the Deploy Windows Azure Project dialog and gives us two options to deploy our project. We can create the service package only, which will create the package and the configuration file on our local desktop, or we can select to deploy our Windows Azure project to Windows Azure through Visual Studio. For this example, however, let's select the Create Service Package Only and click OK. This is going to build our project and create our deployment files that we need to deploy through the management portal. And you'll notice when it's all done, it actually opens up Windows Explorer to the location where the two files have been created. There's our service package file, and there's our service configuration file. And these are the two files that we're going to upload through the management portal. So the next step is to open up our Windows Management Portal. Here's our Windows Management Portal, and you notice that we have several options. There's our hosted services and storage accounts. Here we can create and manage our SQL Azure databases. We also have reporting and service bus and app fabric configuration settings as well. What we want to select is the hosted services, storage accounts, and CDN node. And you'll notice when we select this, it gives us several options on top. We have affinity groups, management certificates, hosted services, and storage accounts, and a lot of this we'll talk through the rest of the course. What we want is the hosted services, so go ahead and click on the hosted services node, and here we have our AppDev Cloud subscription that we have already created. So to create our new hosted service, simply click the New Hosted Service button on the toolbar, and we're presented with the Create a New Hosted Service dialog. Here is where we create and upload our application. If we have multiple subscriptions, we can select our subscription and the subscription we want to upload to. Since we only have one, we're not going to change that. What we do need to do is create a name for our service. So we're going to create Hello World. We're going to name our service Hello World. The next thing we need to do is give our URL. This name must be unique, so we can't call it Hello World because everybody and their dog has probably created a Hello World application. So we're going to call this AppDev Hello World. Okay. Now, more than likely, this is valid because if it was not valid or if it was already taken, it would have told us. So we're good to go there. The next thing we need to do is choose the region. Now, we know that there are 6 data centers throughout the world. There's 2 in Europe, 2 in Asia, and 2 in the United States. So we need to choose a region. And best practices says that we need to choose the region closest to where we are. AppDev is located in Minneapolis, Minnesota, so we're going to choose North Central U.S. Okay? Our next step is to find where we want to deploy our application. We can deploy it to a stage environment, we can deploy it to a production environment, or we can choose not to deploy it at all. Well, for the sake of this example, I'm going to deploy to a production environment. If we were to choose to deploy to a stage environment, this gives us the ability to deploy to a staging environment, and our URL would be a GUID string. So it would be guid.cloudapp.net, but by deploying to our production environment, it would actually deploy to appdevhelloworld.cloudapp.net. This option, the Start After Successful Deployment option, actually will start the service after it has been successfully deployed. We can also give our deployment a name, so we're going to call this V1 for version 1. Now we need to browse to where our package and our configuration files are located so we can upload those. We know that it's located here. So we're going to click Browse Locally. We're going to go to Visual Studio 2010, Projects, Azure Project 1. Let's make sure we have the right Azure Project 1 bin publish. So we went to Azure Project 1, bin, debug, publish, and there's our service package. Now we need to go to the same location and grab the configuration file. So now we have all our settings ready to go. If we were to add a certificate for security reasons, we could add a certificate. We're not going to do that now. So we've configured everything successfully, so go ahead and click OK. And again, as we learned, it will take several minutes to upload and prepare the environment. So we'll come back when this is all done and ready to go. Okay, now that our application is deployed, we can see that it was created successfully and that it is ready to go. You'll notice, though, as we select our instances, there's our DNS name, and this is what we can actually click on to view our application. But what you'll also notice as we look through this information that there's our role, and you'll notice that we have multiple rows. That's because in our configuration file, we specified to run 2 instances. So we actually have 2 instances. There's instance 0, as you see over here, and there's instance 1 that you'll see over here. All right, so there's our role with 2 instances, and there's our deployment. So to see if this is actually working successfully, let's go ahead and copy this. We can actually click on that. It'll open our browser. And if everything's working, we should get, there we go, Hello Windows Azure. So we actually created our application, deployed it to the cloud through our management portal, and once it deployed successfully, we were able to run that. And you can see here that everything deployed successfully and we're running successfully. So congratulations, you have just successfully deployed a Windows web role.